1. Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by TechStrong and SciCode. My name is Cody J. Brown, and I'll be moderating today's session. We have an exciting presentation ahead of us, but before we begin, I have just a few housekeeping notes. First, today's event is being recorded, so if you miss any or all of the discussion, it will be made available to rewatch. You'll receive an email after the webinar concludes with a link to access the on-demand. We want to hear from you, so please feel free to send in your questions at any time throughout the program using the Q&A feature. We'll try to address as many questions as you can send in, so be sure to get them in early. I'll also direct your attention to the chat tab. This is where you can speak with each other, you can speak with us, let us know your thoughts, say a quick hello, or just let us know from where you are tuning in. And finally, at the end of today's webinar, we will have a drawing for 4 $25 Amazon gift cards. Stick around to see if you're one of our 4 lucky winners this afternoon. Let's go ahead and kick off our webinar. The topic today is code tampering, 4 keys to risk reduction. And I'm joined today by Ronan Slavin, co-founder and CTO at SciCode, and Andrew Fife, VP of Marketing for SciCode. It's my pleasure to turn the floor over to Ronan to get us started. Thank you so much for being here with us today, Ronan.
Thanks, Cody. Actually, this is Andrew. I'm gonna get us started. But thanks everyone for joining. We're here to talk about what we think is a very important topic. The headlines that have gone through the media about supply chain attacks have a lot of organizations thinking about how can I protect myself from one of my vendors. But that's really an IT perspective, an IT security perspective. There's also the flip side, which is how can I prevent my organization from becoming the next SolarWinds. And that's what we wanted to talk today about. It's really the AppSec problem, which is how do you reduce the risk of code tampering within your organization? And before we jump into it, let me just tell you a quick little bit about us. So my name is Andrew Fife. I am the VP of Marketing here at SciCode. I've been working in security and security-related industries for really my whole career. Previously at an AppSec company called Shift Left, doing static analysis, and prior to that at Okta doing identity, and before that doing network security for a company called Untangle. So that's a quick bit about me. Ronan, your background's actually much more impressive. Why don't you tell the audience a little bit about how you got started in security?
Thanks, Andrew. So hi, everyone. I'm Ronan Slavin. I'm the CTO and one of the founders at SciCode. Before that, I had a previous startup that was called Filock. That was acquired after about 2 years by a company called Reason Cybersecurity that develops endpoint protection. So I moved there to lead this development and research. And before that, I spent 5.5 years at the A200 unit, both as a developer and a leader at the unit.
Awesome. So 2021, we think, has become the year of the software supply chain attack. And we think that you guys will be familiar with most of the headlines. But beyond the headlines, there's actually been an overall increase of approximately 4x the software supply chain attacks that have occurred. And here are some of the examples of those headlines. But so it's not just the increase from 2020 to 2021, it's also an increase in the future. And so Gartner themselves is predicting that by 2025, almost half the organizations in the world will have had software supply chain attacks, and that's a 3 increase from where we're at today. So if you think about it, we've had a 4x increase from 2020 to 2021. We're going to have a 3x increase from 2021 to 2025. The point here is that the frequency and the severity of these supply chain attacks has increased dramatically, and we think it's now time to really start having them be as important within your security program as anything else. So what we've seen happen in the market is that attackers are shifting their priorities. Historically, the number one target of attackers has been the production environment, using tools, like Metasploit or whatever else. There's a handful of them out there. But today, what we're seeing is that attackers have realized that the actual development tools and infrastructure that make up your software supply chain can be just as lucrative, can yield just as interesting data and results, and oftentimes are a heck of a lot easier to break into. So this is the key change. Attackers are now starting to look at your software supply chain as the weakest link in the chain. But why have those priorities shifted? Well, the first thing is that securing these tools has largely been an afterthought. These are tools that are first and foremost purchased to increase developer efficiency and productivity. And unfortunately, application security and developer efficiency and productivity don't always go together. Second, these are purchased by engineering teams, and the security team often has little or no insight into how they're being used. And third, there really aren't a whole lot of tools that focus on securing the development infrastructure itself. So, of course, if you've got an engineering team that's buying a new tool and the goal is to increase the agility and efficiency of releases, and security is not involved, quite frankly, it's just unlikely that that security is really going to be baked all that well into the process. The second thing is that while there are lots and lots of tools out there to find vulnerabilities within code, and there's lots of tools to protect the production environment. I mean, I like to call all these acronyms the alphabet soup of AppSec. What you don't see in here are tools aimed at protecting the software supply chain. So that in and of itself is an issue. And we ran a poll that we wanted to share the results of you with, which is, what is your biggest unmet need in application security? And while there's lots of emphasis that people put on securing source code and on protecting the app in production, it turns out that from our audience, securing development infrastructure was in fact their biggest unmet need, because it wasn't an easy thing for them to secure. So before we move on, we thought we would see what everyone on this call's biggest unmet application security need is by running the same poll. So let's go ahead and bring that poll up now.
The poll has been launched.
All right, thank you so much. So we'll give everyone here, about a minute to answer this poll question. We'll give it about 30 more seconds here. All right, Cody, do we have time for anyone else to get their final poll responses in, or should we move to the results?
I believe the results have about leveled out. I'll go ahead and close the poll.
Ronan, do you want to share the results with the audience? It looks like the numbers are pretty even, where source code leakage actually got 0. The two leading ones are vulnerabilities in code and infrastructure as code. And then the next places are securing development infrastructure and protecting the app in production. So I guess like the opinions are pretty separated here.
Yeah. Well, different audiences, different results, but it's always interesting to hear and see what people have to say. Moving on. Okay, so the one of the next things that that is making these or that is enabling attackers to shift priorities and helping them want to do that is that all of this progress that we're making in terms of DevOps is actually tightening the interconnectivity amongst the tools that we use and hence amongst phases of the SDLC. So what this means is that moving laterally is actually easier than ever before. So if you want to tamper with code, you've got to control multiple phases of the SDLC to enable to get your tampered with code live in production. But we've actually also made that easier with our DevOps integrations. In addition to that, other modern problems like hard-coded secrets, which you can find throughout the SDLC, also help attackers move laterally. And if you think about it, the SDLC itself really is being concentrated into source control management systems. Whether you want to call it everything as code or GitOps, what we put within our Git repositories is dramatically expanding. Historically, it was just Git repositories were just places for source code. But increasingly, we've got things like GitHub Actions. And of course, GitLab has their equivalent too. But these are really CI/CD settings. So we're starting to use GitHub to control builds and other downstream parts of your SDLC. So that's kind of bringing the build phase into the repository. And we've got things like infrastructure as code, right? Which is how we're going to bring our new build into production. But that code is now living in a repository as well. Oftentimes the exact same repository as the source code, ideally a unique one, but sometimes that isn't always possible. And then we've even got tools like CircleCI, which is a build tool, but it is actually leveraging the identity management or the identity of the users from say GitHub. So what this means is that if I'm an attacker and what I want to do is tamper with code, I only have to get into your source control management system to be able to do that. Because today I can tamper with that source code. I can then use the GitHub action to push a new build, and I can tamper with the infrastructure as code to deploy that build into production. I can really do all of that from within the source control management system. So not only is attacker movement being easier, not only is attacker movement easier than ever across different phases, but the SCM itself is particularly sensitive because all those phases really exist in that one place. So we need to be thinking about attacker movement across all phases, but just extra attention on the source control management system. And so obviously, this is a bad recipe, right? We have security as an afterthought. We've got ease of lateral movement. The value of the target's extremely high, and so this is a recipe. This answers the question of why are we having more attacks on the software supply chain? It's an easy target and it's a high value target, and attackers have noticed. This is where I'm going to pass the torch to Ronan, but I did want to say that there are a lot of new emerging guidelines here as to how you should think about hardening your software supply chain. And we wanted to spend some time walking you through a couple of the most important ones. But our value here is that I think we've distilled all of this guidance into these 4 keys, which we'll talk about at the end. And then the last thing I wanted to note before I pass the torch over to Ronan to talk about these various frameworks is that the Gartner report that we mentioned here that was published in July, not only is it an excellent report, but we also have a complimentary copy of it that we can share with you for for attending the webinar. So we'd be glad to share a full copy of that report with anyone here. Ronan, I will go ahead and stop sharing so that you yourself can share.
Thank you, Andrew. Let me know if you can see my screen.
Yes, I can see your screen. I think we are good.
Okay, cool. So like Andrew mentioned, we are going to look at three organizations that are also working on defining like standards and talking about the problem of software supply chain security and what should be done to address this issue. Like it will be a result of the incidents we've seen in the past year. So the reports that we'll look at, the first one will be Gartner's that published a report in July on how software engineering leaders can mitigate software supply chain risks. Then we'll look at Google Salsa, which is a framework that is developed by Google to address some of the issues as well. And finally, we look at the presidential executive order, and specifically we look at NIST tasks that were derived from the executive order and the current status of it. It's important to remember that this is all work in progress, and these things are constantly evolve and improve. So in mid-July, Gartner published a report on how software engineering leaders can mitigate software supply chain security risks. An important sentence in this report is that this recognition that attackers are targeting software development systems, open source, and DevOps pipelines, and it's important to protect the integrity of the software delivery. If we look at the key findings, so the top three would be, first of all, it's critical to protect internal code and external dependencies. The next one talks about leaked secrets and sensitive data, as well as on code tampering, as issues that should be looked for and addressed. And then finally, the third bullet is discussing least privilege entitlements, having least privilege access control on all these tools, basically, making them more secure and harder to compromise. So Gartner publishes top practices to mitigate supply chain security risks in software development and delivery, and they divide them into these three pillars. The first one talks about internal and external code, so having a strong version control policies, which we'll look at in the following slides, using trusted component registries and having third-party risk management. Then when we talk about the delivery pipeline, so secret scanning and management of secret usage, signing a commit, signing the artifacts, and having a provenance, which we will also discuss in the next slides. And then finally, hardening the security of the tools themselves, of the tools that you use in the CI/CD pipeline, making sure that you use the best practices within these tools. Each tools come with its own configuration and things that you should be aware of. And it's not always the case. So really understanding what are the things that you should look at and making sure that you address them. And then finally, they have the pillar of the operating environment, where the first bullet is least privilege access, like we mentioned earlier. So least privilege access control across the tools increases the resilience to attack and makes them much harder to compromise. Having machine identity management and anomaly detection and response. So it's not enough just to have like this strong control. You still also need to have constant monitoring and look for any anomalies and response to any suspicious activity. Gartner also talks about the risks that are exposed in your supply chain. They divide them into these four basic steps of the delivery pipeline. So developing the code and the risks that might be exposed there. So certificate theft, hard-coded secrets, having the credential being stolen, and other scenarios. Then during the integration and build, so threads that are related to open source vulnerabilities, to open source issues like typo squattings and the likes. Then in the deploy, so looking whether the signing certificate was replaced or any of the automation scripts have been tampered with. And then finally, during the deployment and post-deployment, and then updating the existing versions. So did someone access my production environment and replace the files and things like that. Then if we sort of do a quick deep dive into the strong version control policies and look at what are the action items that Gartner recommends there. So the first one would be to enforce access policy control. So again, they mentioned these issues of granular role-based permissions. Within the tools, there's different levels of permission. For example, in repos, you have write, you have read, you have administrator, and even more. So looking into all that and making sure that you have a least privilege, obviously enforcing multi-factor authentication to access these tools, and zero trust access-based as another sort of access, secure access solution. Then the second part is really having strong configurations that you should make sure that you use within these tools. So things like enforcing branch protection rules. They would have all kinds of sub-configuration that you should be aware of. So things like requiring signed commits, basically making sure that the developer signs the commits that they push, prevent forced pushes, which protects the repo from any history modification or any changes that sort of cannot be tracked, and require status checks to pass. So make sure that your tools run and check the code before you allow merging code into your production branches. And then finally, they have this, they address the issue of secrets. So having pre-commit hooks to make sure that developers don't commit any sensitive data, scanning for exposed secrets, and then obviously addressing them, and have automated and manual code reviews that make sure that there are no secrets as part of the development workflow. So this is the first organization, Gartner, and the recommendations that they offer. Then in May this year, the executive order was published, and the executive order on improving the nation's cybersecurity. Basically, it charges multiple agencies with enhancing cybersecurity through a variety of initiatives. They talk about the security and integrity of the software supply chain. Specifically, Section 4 requests inputs from the private sector, from the academia, from government agencies to help in developing these new standards, tools, best practices, and guidelines that would help to enhance the software supply chain. And this would be things like from how do you evaluate software security, how do you evaluate the practices and the developers, and what tools are missing right now and should be created to sort of help address this issue and problem. So if we look at how Section 4 starts, so we can see that they mention immediately the development of commercial software often lacks transparency, sufficient focus on the ability of the software to resist attacks, and adequate controls to prevent tampering by malicious actors. Basically, they mentioned that the software supply chain is vulnerable, and this is an immediate risk that we should start talking about and addressing. Then if we look at sort of the NIST tasks that were derived from the presidential order, so we have these 6 main tasks that were derived. The first one is to define what is critical software. Obviously, critical software is something that we would want to make sure that has the strongest level of protections. Then what are the security measures that should be used for critical software? Guidelines for what is the minimum standard for testing, mainly to detect vulnerabilities and issues within the code. Guidelines for enhancing software supply chain security. Guidance on identifying practices that enhance the software supply chain security. These two, the results of these two was the SSDF framework. And finally, initiate a pilot program that identifies IoT and secure software development practices and a criteria for consumer labeling programs, which is something that is being discussed right now, and we'll also mention this briefly. So this is how the timeline that NIST derived from the executive order. As you can see, we are in the square right here. The previous tasks were completed. It started with day zero where the executive order was published. Then the first thing that NIST did was to solicit inputs from stakeholders. Basically, NIST turned to the industry, to the academy, and asked people for their opinion on this issue. And then they created these working sessions on each of the action items that you see here. Critical software was published. Guidelines for enhancing security is eventually something that resulted in the formation of the SSDF, which is in an initial draft. And consumer labeling is also something that discussed right now. But sort of the deadline for all this task is May 2022, where they're going to review and submit a report in the pilot programs. And we can see some of the companies that participated in providing input and helping NIST with this task. So we can see like very big companies here, like from Microsoft to AWS to other major players in the industry. Then I'll try to sort of do a quick overview of some of the action items or some of the deliverables that are part of these tasks. So one of them was defining security measures for what is defined as critical software. So the 5 main points here is, first of all, to protect the software and the software platforms, the tools that are used to develop the software from unauthorized access and usage. Then we need to protect the confidentiality, integrity, and availability of the data used by the software and the software platforms. The next bullet talks about identify and maintain software development and software deploys to these platforms to protect the critical software, detect and respond and recover to threats and incidents that are part of the threats that exist on the software delivery and software platforms that are used to build software. And finally, educate the people that are part of this process to be aware of the risks, to be aware of the issues, and eventually mitigate the risks by making sure that the people that build the software are aware. They work using the best practices, the tools are secured with the best practices, and they avoid making common mistakes. The next two deliverables are the SSDF and consumer labeling. The SSDF is the Secure Software Development Framework. The draft was updated in the last September in response to Section 4E, which is again one of the sections in the NIST items. Obviously, there was a draft. This was the first draft. The second one was in October, which addresses Section 4C. And in addition, NIST is discussing this consumer labeling, which basically means that NIST is required to identify for IoT cybersecurity what is the criteria for a consumer labeling program, and what are the secure software development practices and criteria for software development. So basically define what should be checked when we build this label that ensures like that the end product came from a secure software development pipeline. So the sort of the high level goals of the labeling is that it encourage innovation from the community. It should be practical and not burdensome. So it shouldn't be something that is hard to implement and use as part of the process that you already have. It should factor in the usability as a key consideration. So again, making sure that it's easy to use. And it should rely on the national and international experience and be open to several approaches. Again, software development is very different between different organizations, and maybe not all maybe there isn't a single approach that fits all. So maybe several different approaches should be used, and then according to the specific vertical, and this way, like each of these would be more secure. The first draft was published for the consumer labeling. Again, the goal is to establish a baseline set of technical criteria to make sure that companies that build software are informed of the responsibilities they have when they provide such a solution. And the label should tell the consumer that good practices for secure development were employed during the software development lifecycle, and that there's a consideration in software and software architecture when these products are created. And the labeling should include like how cybersecurity risks and attributes could be represented, how the labels can be tested for effectiveness, how the public can be educated, and how can the public be aware of these labels and what it means. And then like how organizations should attest to this labeling framework. So again, this is something new. This is something that doesn't exist right now. But eventually it's an important goal that sort of says to companies that build software, you have a responsibility on the process. And as clients, they would want to know that you take this issue seriously and that you address it accordingly. And again, in the draft, there's an example of the attestation that this labeling would provide. So it describes all kinds of stuff on the software itself, like who is the provider, date, and things like that. Some attestation on the software development, so sort of prove that you use a secure development process. Attestation on the code itself and the attributes of the code, so that there aren't any known vulnerabilities, that you can trust the integrity, and there is provenance that proves this integrity, that multi-factor authentication was used, that there aren't any hard-coded secrets, and if it's a tool that uses cryptography, so that the cryptographical standards or the cryptographical methods that are used are strong. And then finally, they have these aspects of having data inventory and protection attestation, so making sure that they protect personal identifier data, location data, and data that is specific to the application. So this is sort of an overview on the NIST part in defining how to reduce the risk on software delivery pipeline. Again, this is work in progress, but it's very interesting to see sort of the work that has been done so far, and will be much more interesting to see how it affects the future and whether this labeling is adopted and how. Then we get to our final framework, which is Google Salsa. So Salsa is a supply chain level for software artifacts. It's basically an end-to-end framework to ensure the integrity of software artifacts through the software supply chain. The goal is to improve the state of the industry. It is particularly aimed at open source to defend against the most pressing integrity threats. And it's focused on the process of building and shipping the code, and not specifically the content that go through the pipeline. So it doesn't talk about like vulnerabilities in code or vulnerability in the dependencies or in infrastructure as code, or even the cloud environment and whether someone changes something there. It specifically focuses on the build part and the provenance phase for this build part. The way the framework is built is that they define 4 levels of Salsa. If you have level 0, it means that you're not following anything in the standards. If you have level 1, it means that the build process that you use is fully scripted, automated, and it generates a provenance. Provenance is sort of the proof, sort of the documentation of how the build happened. If you're Salsa level 2, so it means that you require a version control and that you use a hosted build service that generates an authenticated provenance. In Salsa level 1, the provenance is not authenticated. Then if we get to level 3, so it adds all kinds of security ability of the source and the integrity of the provenance and the build process. And finally, we get to Salsa level 4, which is the highest standards in this framework, which means that you require 2-person review of all the changes and that you use hermetic reproducible builds. This means that your build process can be reproduced and then verified against the artifacts that you are publishing or that you are using. Another way to look at it, or sort of an example of each of the levels. So an example for level 1 would be an unsigned provenance. It's me giving a document that says this is how I build the code. It's unsigned, it's hard to trust it, but this is Salsa level 1. The second level, I would use a signed provenance, so I would use something to sign. It means that you can check the provenance against my signature as a publisher. And one of the things that you will see there is that I use a hosted source code management system and a hosted build. Then if we get to level 3, so I have some security controls on the host of the code and the build, and you can't falsify the provenance. The provenance is created in a strong enough way that you can trust that it came from me. And the fourth level, again, we go back to a 2-party review and hermetic build. Again, obviously, with all the requirements that come from Salsa 3 and Salsa 2, which means that I generate provenance that proves this, and it's non-falsible, and you can verify it. Similar to what we saw in the NIST framework, Google Salsa also talks about the risks that are part of the software delivery pipeline. So we can see all kinds of threats in the different phases, from a developer submitting malicious commits to compromise of an entire tool, like the source control or the build platform. And these are some of the risks that this framework tries to address. To address these risks, sort of the requirements are divided to 4 categories. Source, which are requirements that are related to source control. Build, which is related to the build phase. Provenance, which is, again, the document that you would supply with your artifacts that proves what was the build that was used, what was the source that was used, and we have these characteristics that can be verified. And then finally, common security controls that are common across all the tools that you use as part of your software delivery pipeline. And we can see what are the requirements for each Salsa level, and I'll walk you through briefly each of these. So in the source phase, to get Salsa level 2, you need to use version control so that every change can be tracked. To get to level 3, you need to have a verified history. This means that you need to disable forced pushes. It means that every change has a strongly authenticated user in time, retained indefinitely. So it means that no one can change this history. This is the force put definition. And to get to level 4, you will need both this, retained indefinitely, as well as 2-person reviews. Then when we get to the build phase, we talk a lot about like how is the build being run and how is the build system managed. So Salsa level 1 simply means that you use a script. It means that you have a build script that you run, and the command that generates the build. To get to level 2, you need to have some build service that takes build steps, and the build doesn't run on a developer's workstation. And then we get to level 3 or 4, where the requirements are mainly on what is the type of build system that you use and how is it implemented. So in level 3, you would need to use a build system that uses ephemeral environment, meaning that a new environment is created each time you do the build, and you build it on that environment, and it should be isolated from other execution and other influences, so that it would so that attackers won't be able to intervene with it. Then to get to level 4, the build should be parameterless and hermetic. So parameterless means that it shouldn't change according to some parameters. And hermetic means that you know what are all the steps, codes, and dependencies that you use. So let's talk about the dependency. For example, you don't use the latest version, you use a specific version that, again, this can be used to to create a eventually reproducible build, but also to know exactly from the provenance what is the content of the build, the artifact. And then finally, we see this new notion that is O, which means best effort. And this talks about reproducible builds, having the ability to run the builds within the same conditions on different point in times and getting the same artifacts. This is not how most builds work right now. And organizations that can get to a reproducible builds would enjoy a stronger level of protection, because you'll be able to create a parallel build and make sure that it matches the build of the originating system, and by that detect any sophisticated tampering against it. And then we talk about provenance. So we want to be able to prove what is the process that we did and how was the software created. So there's all kinds of requirements for the provenance. Again, the first one is just to have it available, make sure that you supply it. Then we get to level 2, which means that it's authenticated and created by a service. Then if you get to level 3, it means that it can be falsified. And at level 4, it is dependencies complete, meaning that we know all the dependencies, all the machines, all the virtual environments, Docker images that are used, and they're all in a specific versions that can be that we can know, and not a version that is floating like latest or things like that. Then they also mention like what is the things that should be within the provenance. So it should be the artifact. It should include what is the builder, what was the source that was used to build, what is the entry point that was used to run the build script, the parameters if it's not parameterless, other dependencies, if it can be a reproducible build, so the reproducible build info, and other metadata. Again, this is best effort. And finally, the final aspect, which is the common, it's common requirements for every trusted system that is involved in the supply chain. So the code, the build, the distribution, and others. Obviously, the first requirement was to make sure that these systems are secure. So making sure that they meet some standards, that are patched, that they are scanned for vulnerabilities and the likes. The access to these tools is gated behind the multi-party approval, and that remote access and physical access is rare to them. And finally, looking at super users, administrators, the owner, they always have the permission to override some of the security gates, and you need to make sure that you only have a small number of these types of users, and also look at their activity. This is a quick example on how provenance look. Again, the goal is to show what is the build. So here we can see that the build downloads example 123 tar.gz, extracts it, runs make -c with some flags, and eventually resulting in a file that has the hash 5678. So this is, again, a very basic example of Salsa level 1, but it sort of helps bring it down to what is provenance and how it should look. And this wraps the Google framework. Andrew, I'll pass it back to you.
All right, thanks so much. Let me get my screen shared appropriately. Okay, and hopefully you can see my screen now with 4 pillars to reducing code tampering risk. So thanks to Ronan for covering all of those frameworks in such detail. What I wanted to try and do is distill down a couple of key themes. And when we think about these 4 pillars, the first one is critical code monitoring. Second one is file integrity verification. Then we have the concept of defense in depth. And finally, anomaly detection. So we want to start by talking about critical code monitoring. And basically, this is just the idea that in theory, if you could look at and verify every single change to every single piece of code and have the context to be able to make sure that each code change was legitimate, boom, done and dusted. We could be done with this whole code tampering. But the problem is that our actual application code bases are large, they change frequently, and simply looking at while peer review is a good step, it's not infallible. So there are, it turns out, certain parts of our code that are small enough and important enough and change infrequently enough that we should look at every single change. And so what we're suggesting is that step one is that for these critical code, you should be alerting and you should be looking at every single change. So that's going to be the things that we have listed here. It's your CI/CD settings and your branch protection rules. Why is this important? Well, it's important because if somebody's going to start trying to tamper with your code, one of the first things they want to do is potentially start evading some of the security rules that you have set in place. So we want to make sure that anytime there's an update to things like branch protection or build security rules, that we're looking at those, that they never happen without us knowing. And then same goes for on various levels for infrastructure as code, your dependency updates and hard-coded secrets. We're seeing more and more typo squatting around dependencies. So you want to make sure that you're not automatically pulling an update or that somebody hasn't pulled an update maliciously to point at a malicious typo squatted repository. So critical code monitoring is an important first step. The second step is file integrity checks, and there are many, many different handoffs throughout the SDLC. And so it's a great idea to assume that any system can be compromised, and so that we're not just blindly accepting inputs from earlier parts of the SDLC, that we're actually checking to make sure that that those inputs are as we expect them to be. So the first example is, hey, between code and CI, we want to make sure that we're commit signing and that we're using Git's hash-based integrity to verify that the code is as intended before we run that build. And then within the build itself, we want to try and use reproducible builds to verify that the build system itself wasn't tampered with. And as we look later in the SDLC, we want to verify the build outputs against our published and our operational artifacts, so that an artifact hasn't been tampered with and maybe injected into production that didn't come from an approved registry. But there's a gotcha here that I'm going to leave as a cliffhanger. We're going to come back to in 1 second, because just because we do all these checks doesn't mean that we're necessarily stopping tampering. So I'm going to come back to this in a second. But the next pillar is defense in depth. And really the way to think about this is that, we talked about the importance of lateral movement. And so we want to do everything that we can to make it as difficult as possible to peel those layers of the onion. We want to be able to have the DevOps automation that is automatically passing data between different phases and tools of the SDLC, but make it hard for the attacker to do that as well. And where we see the biggest problems here is that people just simply assume that the basics are covered. And based on that assumption, that means they don't check. And so over time, basic things become weak. In particular, it's authentication and it's authorization and it's the security policies. So what you want to think about is a model where you are able to consistently apply those governance and security policies across all the teams and tools and phases of your SDLC. So in particular, these days attackers are going after developers' accounts. So we really want to make sure that we've got strong authentication policies in place, the core of which for many is going to be MFA. But there are other aspects to that. How often am I challenging for the token? Am I using SSO? Do I have IP range restrictions? And then, of course, if somebody is who they say they are, do they need access to all of the different repositories, within my organization and all of the different tools? If I can enforce a least privilege policy across all my tools and I can actually audit for excess privileges, then not only can I make it harder for external attackers, but I make it harder for rogue employees as well. And then lastly, having those what the appropriate security policies in place every step of the way, whether it's a branch protection or a build rule. It just makes it a little bit harder for somebody to get something through. But something to note here is that down at the bottom of the screen, we've got so many different tools that this can become complex quickly in enterprise environments, because it's not just one team looking to make tools operate in concert across different phases of the SDLC. It's often multiple teams. And those teams might have, there might be teams working on legacy apps that have totally different tools. And of course, within the software industry, we love nothing more than to acquire each other. There's so much M&A activity that who knows, what the team that you acquire and bring in the door is going to have in terms of their security settings. So it's really important to start thinking about, how do I centrally manage and apply all these policies so that I have good governance across my entire SDLC. And now coming back, with defense in depth, I want to tie this back to the integrity concept that we talked about a second ago. We talked about this notion of, if I sign my commit in dev and I verify that file and build, that I can wind up, trusting the integrity. But now I want to unwind that and say, well, wait, hang on. If you look at the way that SolarWinds code tampering, that SolarWinds code was tampered with, unfortunately, the SolarWinds team had no idea that the updates that they were pushing for their Orion platform had been tampered with. So in the case of actually deploying that update to their customers, all the appropriate signings were in place. So if the customer was verifying that that software was good, it looked good. So this begs the question: how do we know that the original code actually is good in the first place? I mean, we could just be verifying the integrity of malicious code in this example. So that's where we want to start marrying file integrity with this concept of defense in depth. So we start taking some of the things that we talked about before, and we say, why should I trust the initial commit signing? Is the committer authorized for this repo? Is the committer who they claim to be? Are the keys that we're using legitimate? Are there any mistakes in here that we can hopefully, find out via peer review? What are the committer's intentions? A good example here is that for some reason, oftentimes the provisioning and deprovisioning of developer accounts is outside of the normal provisioning and deprovisioning of standard user accounts. So it's not uncommon for somebody who's left the organization to still have access to GitHub. And so if you've got somebody who's making commits that's no longer an employee, I mean, that's a really bad sign. So if we can marry the concept of defense in depth with our integrity checks, then we can start to build the confidence that we should trust the signing in the first place. And then the last thing, and arguably the most complicated, is identifying anomalies. We've got some examples here on the right side, but I'll pose just a simple one, which is something that can be a challenge, but is something that that we probably should start looking at, and that is, we've all got naming conventions in terms of how we're doing our commits. And so if you've got a naming convention that starts with hypothetically 123 space dash space, and then the title of that commit, and somebody comes in and doesn't use that naming convention, well, okay, I mean, that could just be a new employee who's learning what the naming convention is. So we put that aside, and maybe we don't worry about it for now. But then if they also go ahead and try and push that commit, try and do a pull request on it to get it into the main branch right away, that now becomes suspicious when we combine those two things. Because why would somebody who doesn't know our naming convention be trying to get code into our main branch right away? That's a sign that you've got an outsider who's attempting to inject code into your main branch. So by combining these four pillars, we start to really reduce the risk of code tampering. And with that, we'll go ahead and wrap up. I think we are just about out of time, so I don't know if we really have time for a demo, but we could certainly take a couple of questions. So maybe we'll just go ahead and move on to that. let's see. If anyone has questions, I would encourage you to ask them now. Okay, looks like we got one here, and that this question is, you mentioned GitHub a lot during the presentation. Is GitHub any more or less insecure than the other major Git-based source control management systems? I don't personally have a strong opinion on that. Ronan, do you?
So to me, I think GitHub is doing a job that is a little better than the other tools. We we work closely with with the APIs and the capabilities of each. So GitHub, at least from our point of view, is the most full. So I would say that they are.
Okay. The next question here is, where would you recommend that we start with our risk reduction program?
So to me, like the first thing is to first of all like map what you're using. What are the tools that are in your organization? What do you use for code management? What do you use for your build, for your as part of your CI/CD, for deployment? Really mapping this out. Then once you know what are the tools that you use, you can start working on the first two layers that we've mentioned here. The first one would be access. So looking at who has access to these tools, what is the level of access that they have? Is it read? Is it write? Is it admin? Do they need this access? Maybe you have past employees or contractors that still retain their access somewhere. So making sure that you have good hygiene around that. And then immediately you can also start working on the second level, on the second sort of layer, which is hardening the configuration. So following best practices, again, according to each tool that you use. So for example, for code repositories, looking at whether you have branch protections. If you do they meet the sort of level that you expect from them, like enforcing two-person reviews, disabling forced pushes, and also things that we tied back here. And this would apply to all of the tools. So if you look at the build phase, so things like what are the orbs that you're using and things like that. This would be the first places that I would start, and then obviously move on to more advanced things like cleaning secrets, making sure that your secrets aren't committed, looking for leaks that you might have and understanding that, looking at infrastructure as code and CI/CD configuration within the repos, their security, and their drift from what's happening in production, and then finally having anomaly detection and custom policies that would look for specific issues that are relevant to your organization, like the example Andrew gave with the commits that don't follow your guidelines.
Cool. Well, that just leaves us with 2 minutes left. And I think is there a raffle to do at the end of this one, or?
There sure is. So if you'd like to take this time to close out with any final remarks you may have, now would be the time.
Yeah, I guess I would just say thanks to everyone for joining. The frameworks provide a very good guideline, but there is no uniform way to address this problem because it's so new. And we hope that our 4 pillars give you, a good place to start. Ronan specifically mentioned asset inventory, and couldn't agree with that more. You got to know what you have in order to start hardening it. And then lastly, we do think that all of this information, all of these frameworks have some value. The Google Salsa and NIST and the executive order, that's all publicly available information, but the Gartner recommendations are not. That being said, we do have complimentary copies of that we can share. So we'll email those out after the webinar, likely tomorrow.
Outstanding. Well, thank you both, Ronan and Andrew, for taking the time to be with us today and answering all these questions. I'd like to announce our 4 winners of the $25 Amazon gift card drawing. Our first winner is Raja C. Our second winner is Taymor W. Our third winner is Gervais B. And our fourth and final winner is Molly P. Congratulations to the 4 of you. Keep an eye on your inbox to claim the gift card. And if you don't receive an email, check your spam folder. Quick reminder that today's session was recorded. Following the webinar, you'll receive an email with a link to access the recording on demand, or you can find it here shortly, located on the Security Boulevard website. Ronan and Andrew, again, thank you so much for putting this together. And I'd also like to thank you, our audience, for being with us for the entirety of today's presentation. This is Cody J. Brown signing off. Have a great day, everyone.